In today's video, I will show you the fastest and the smartest method on how to derive current divider rule using Ohm's law and KCL. Let's dive in. So in the circuit above, we have resistor R1 and resistor R2, and also we have the supply voltage which is V, and the supply current which is I, and the current that flows through resistor R1 is I1, and the current that flows through resistor R2 is I2. Also, the voltage that drops across resistor R1 is V1, and the voltage that drops across resistor R2 is V2. And this is a what? Parallel circuit. We know that in a parallel network, voltage is the same. The voltage that drops across resistor R1 and across for R2 is the same as the supply voltage. So with that statement, I can write that V, which is the supply voltage, is equals to V1 is equals to V2. So we can call this equation what? 1. We also know that in a parallel network, current differs. The current that will flow through resistor R1 is different from that which will flow through resistor R2 because of what? Current depends on what? The resistance level. It is the resistance level of a resistor that will determine the amount of current that will flow through the individual resistor. So with that statement, I can write that the supply current, which is I, will equal to what? I1 plus I2. If we sum these two currents, it will give us what? This I, which is KCL. If we should sum these two, it will give us this I. We can call this equation what? 2. We also know that the standard formula for calculating the total resistance in a parallel circuit is given by ROT, which is RO, is equal to what? R1, R2, all over what? R1 plus what? R2. We can call this equation what? 3. So here are the properties of what? Parallel circuit. Since voltage is the same in a parallel network, our aim is to look for that value of what? Voltage. So by looking for this value of voltage, we will recall Ohm's law, which states that V is equal to what? I. This V is this value of voltage that it was the same. And since we are getting V, and we know that V is equal to I arrow, and we know the value of arrow, that arrow here is R1, R2, or what? R1 plus R2. We will now substitute this value of arrow into this equation. So we have that V will now equal to I, which is this I, into bracket this, which is R1, R2, or what? R1 plus R2. So we can call this equation 4. Equation 4. So whenever we see V, we will put this value of what? V. Since we are putting the value of V that is the same in this parallel network, we will now look for the word, the value of the individual word current, the current through what? Each branch. And we can get that from Ohm's law, which states that V is equal to what? I arrow. Since it is current that we are looking for, which is I1, I2 we are looking for, we will make I the subject of the formula. So we divide both sides by the coefficient of I, which is arrow. So divided by arrow, I will take away arrow. So therefore, I will now equal to V all over arrow. So with respect to this, we can now find the value of what? I1 and I2, which the current that will flow through resistor R1 will now be I1. With respect to this, will be equal to V all over what? R1, I1, R1. But we know the value, but we know that V is equal to this, is equal to I multiplied by R1, R2 over R1 plus R2, which is this equation 4. So we will substitute equation 4 into this. Where we see V, we will put this. So we have that I will now equals to what? I into bracket what? R1, R2, all over what? R1 plus R2 into bracket. Divide by what? Divide by what? R1. Are you seeing? So at this point, we can write that I, which is I1, I1 will now equals to I, which is this, into brackets R1, R2, all over what? R1 plus R2 into brackets. Because this is division, it will be divided by what? R1. And to change this division sign to multiplication, we will take the reciprocal of this R1, which means I1 will now equals to I, which is I all over R1, R2 all over R1 plus R2 times 1 all over what? R1. Are you seeing? So now at this point, R1 can now cancel R1 here. So we left with I1 will now equals to I into bracket R1 all over R1. Sorry, into bracket R2 because R1 cancel R1. We will left with R2 into all over R1 plus R2. Are you seeing? So this is the word, is the formula. This is the formula that we will use to calculate the current to the what? R1. So this is the current divider rule formula that we will use to calculate the current to the R1. So for us to find I2 now will now equals to what? V with respect to Ohm's law. V over what? R2. We will substitute the value of B, which is equation 4. The value of B is I into bracket R1 plus R2 over R1 plus R2. We will substitute this value now into this. So I can clean here. Let me clean this part. So by substituting the value of B into this equation, we will have that I2 now will now equals to V is what? I all over R1, R2, all over what? R1 plus R2 divided by what? I R2. Because we are looking for what? The current across two raised to what? R2. So now we will have that I2 will now equals to I into bracket R1, R2 over R1 plus R2 divided by what? R2. Because this is division sign, so it will be divided by R2. So for us to change this division into multiplication, we take the reciprocal. So I2 will now equals to I into bracket R1, R2 all over R1 plus R2 multiplied by 1 all over R2. So therefore, R2 you can take away R2 here. So we will have that I2 will now equals to what? I into bracket R1 over R1 plus R2, which is the same thing as, let me clean here, which is the same thing as I2, which is equals to R1 over R1 plus R2 multiplied by what? I. So this I now is the supply current, while this I2 is the current across, that is to what? R2. So now this is the word current divider rule formula that we will use to calculate the current through the what? R2. What is current divider rule? Current divider rule helps us to calculate the current through in the individual resistor without solving the entire circuit again. It is a shortcut that saves time in what exam. So current divider will help us to calculate the current through the individual branch without solving the entire circuit again. So if this video was helpful, do well to like this video and subscribe to my channel so that whenever I upload a simplified video like this, you will be notified. And don't forget to drop any topic that you are struggling with in circuit theory analysis. Drop in the comment section and like and subscribe to this channel. See you in my next video. Bye.